Hello, I'm Peter Gostev. You're watching the Cloud Therapist channel.
Hello and welcome to the Cloud Therapist channel. I'm Richard Simon. AI Pragma, that is the title of our talk for today on this panel discussion. The term itself is actually a Greek word, which means deed or act. Now, in this context, it's actually more about kind of being practical and pragmatic around AI, and hopefully we will have that in our discussion. I also incidentally found out that in computer programming terms, pragma is actually a directive for the compiler as well. Something I didn't know before, but just a little bit of trivia there for you. Okay, and hopefully part of our sort of takeaway for today on this talk is really kind of understanding and exploring a little bit more how enterprises can actually implement AI practically, and what does kind of such a deployment look like? How does that actually going to work? So without further ado, let me introduce you to my two fantastic guests. So I'll ask them both to introduce themselves rather than kind of me fumble through the intros and the bios. So Peter, if I can ask you to start first, please.
Sure, thanks for having me. My name is Peter Gostev. I'm head of AI for Moonpig at the moment. But until about 3 months ago, I was at NatWestern Advanced Analytics team. And just generally, I spent about a decade and a bit in financial services and in consulting and startup. And I would say probably 18 months of my life, the last 18 months of my life were all generative AI, kind of when you wake up 9 to 5 and then until I go to sleep. So yeah, looking forward to having this conversation.
Fantastic. Thank you, Peter. And Matteo, if I can ask you to do your intro as well, please.
Yeah, sure. Good to be here, guys. So I've been in the space a little bit less than Peter, and I come from a non-technical background. So I was working at SAP up until March last year. Took some time off to spend some time with family, enjoy the rest of my 20s, and have a bit of a break to research things that I actually found interesting. And I was doing some consulting work at the time, came across generative AI, and you could imagine the profound impact that it had on some of the work that we were doing. And from that point onwards, I've been similar to Peter, 9 to 5 at at my girlfriend's expense, and she'd attest to that as well. So it's been a really interesting year, and now I find myself researching the topic quite a lot, acting as an advisor for 33A, as well as a couple of other businesses, and more recently had the privilege of joining a small team of really talented devs, and we're building some tools for enterprises. So very keen to be here and chat about the topic.
Fantastic. Excellent. Yeah, I mean, I know you guys are both prolific on LinkedIn with your posts and things, and quite opinionated, and I really love that. And I think that was kind of the main attraction that I kind of wanted to really have a great conversation around AI, sort of a little bit sort of on the general side, but also, as we said, kind of focus a little bit more on the sort of the practical side of it. And I thought, well, I've got to get these two guys on the talk with me. I think it'll be fantastic to do that. So welcome both to the channel. I appreciate your time. Okay, so let's kind of just start with a few sort of AI terms and definitions. There's a lot of that kind of sort of stuff flying around. We're not going to obviously be able to do those justice. People can go to Copilot to actually ask if they really want to kind of get the definitions, or do the good old search on Google or something and kind of understand it. And again, there's plenty of videos and things like that. For the viewers, I will try and include, I think, both Google, Microsoft, and even AWS's announced lots of free training on AI. So I'll include lots of links in the description of the video. So do check those out later on. But yeah, let's kind of just maybe start with a few of those. And the first one I've been trying to answer for myself in the last 12 months is really why kind of AI now? What's kind of been the rage sort of since last year, since 2023, and why things like ChatGPT now? Maybe Peter, if I can start with you.
Yeah, so ChatGPT really changed the game in terms of usefulness of AI. So before that, large language models have existed. So OpenAI, the ChatGPT first model was GPT 3.5, so which implies there were kind of two and a half versions before that. So GPT-3 already existed, was pretty useful for more technical people who put time into it, and there were a handful of products that came out of it, such as GitHub Copilot, for example, was kind of based on that. The problem was that to actually get it to do something useful was quite hard. So one example is that if you asked it what's the capital of France, it might reply what's the capital of Germany. Because for all it knows, you were just listing questions,
right?
So, and the big innovation with ChatGPT was to instruction tune it. So that's all of the chat models that we've got right now are all instruction tuned. And what that means is that suddenly, when you ask it a question, it would actually answer the question because we gave it that feedback. That's how it should behave. So suddenly, even though I think reasonably some maybe more technical minded audience could say, you know what, nothing's changed, it's all the same model, but in practice we came from something that was nearly impossible to use for normal people to any school child can now ask a question, get an answer. And I think that change in the way just any humans could interact with it, I think really sparked something in the audience, and then now it's everywhere. And clearly we had this really impressive year and a bit of new innovations in that space.
Excellent. And Matteo, what's your thoughts on kind of where we are now, sort of 12 months later or so?
I think the same basic principles still apply, right? That if there is a tangible business benefit to implementing a technology, then you should do that. And that's kind of what happened with generative AI or AI in general, right? Is it pre-ChatGPT? The use cases that made sense were the ones where there was a multi or $100 million return because it really cost a lot of money and people, time, resources to make that use case worth it. So you needed a return that justified that. Post ChatGPT and the incredible cost reduction that's happened in how we can use this technology, the same thing still applies. You're just looking at a much different relative return based on the cost to the benefit. So I think that 2023 seemed a lot like experimentation and finding out what is good and what is not good.
Yep.
A lot of what I'm seeing this year is around, well, is there a benefit and can we measure it? I'm not sure if that's what you're seeing as well, Peter, but there's definitely been a turn from, okay, what is possible? And, yes, it's cool compared to, does it actually give us a quantifiable benefit?
Okay, yeah, so that's kind of maybe a combination of things. I mean, I certainly found that the investment that Microsoft had made in OpenAI back in 2019 actually was a factor. And it was really hard trying to actually dig up the history of that and to kind of get the why factors for that. But there was a presentation I attended, and somebody said, yeah, it was actually because Microsoft saw what OpenAI was trying to do with what Google had originally produced around the transformer model white paper, and they made the investment in 2019. And obviously the other thing was kind of making things like ChatGPT available to the public. And that's kind of, I guess, and then we kind of let TikTok do the rest really, and kind of went viral on TikTok and kind of went from there. Okay, so transformer model. This is another sort of a concept that's come up. I just kind of mentioned Google kind of was the first to sort of offer that idea. I think back in 2017 was the paper that came out. So Peter, what's around the transformer model in a nutshell?
Yes, I think there are a few interesting things about transformers. So one point is that transformers are very good at working with sequential data. So, which means that if we give it a bit of text, it's quite convenient to train those models. So next token prediction is the way we train those models. So that transform models inherently good at that. The second point that they're good at is they're good at looking at large swathes of that data. So while previous models might have looked at, for example, what's around what you're trying to predict, but that's no good if you're trying to write a longer piece of text code or like a novel or something like that. You really need to look at the whole sequence. So those couple of innovations there really made it much more useful. And another thing that really allowed us to gain a lot of benefit and scale those models is that now, because of these factors, we could actually put a lot more data, put a lot more compute towards it. So that way, once you're able to really crack this idea of how do you scale, then it becomes much more a matter of let's buy more GPUs, let's have more data, throw it in there. And of course, it's much more complicated than that. But once you're able to do that, then it becomes really a scaling game. So that's what we saw as we went from GPT-2 to GPT-3 and 4. It was much, much more compute, much, much more data. And that's what's really enabled that innovation in the space.
Yeah, and not to obviously not to confuse it with the films of the same name, the Transformer franchise. That's obviously something completely different. Okay, Matteo, on the some of the other terms sort of around this space is, you know, things like generative AI, large language models. What's kind of your sort of definition of those? What would you kind of, how would you summarize those?
So I'd probably just backtrack to like machine learning as a whole and say, okay, what we have with this technology is something that is able to learn iteratively on these huge amounts of data to find patterns in that data and then make decisions on that data as well, right? And in an ideal scenario, there's minimal human intervention throughout that entire process. And that's like, I think, a very good standard definition of machine learning, where you, like I said, have something that is iteratively learning on huge data sets to find patterns and then make decisions on that. So within that subsect of machine learning, you have these concepts of, you know, deep learning and neural networks. And when you look at neural networks, you're talking about these really like these networks of nodes that are trying to mimic or replicate some of the functionality of a brain, which is that we input stimuli, we have this stimuli in our lives that is going on. Our brain is processing that, it's creating connections based on that stimuli, and then it's creating some sort of output on that. So an example being, you know, we know to not go near fire because we have a recorded pattern in our brain that fire is hot and burns us, so we stay away from it. These neural networks, this technology is trying to mimic some of that, where as different inputs come in, there are patterns being created throughout the nodes in that network to create an output. Now, a large language model is using a neural network and some natural language processing to sift through huge amounts of data, kind of like condensed words and data sets that are turned into numbers, to find patterns within those numbers and then predict next words. That's kind of what's happening. And this is a layman coming at it, like Peter, who has a really strong technical background. So feel free to roast me here, Peter. But that large language, to me, that large language model is this, like I said, this neural network combined with natural language processing that is finding connections in all of this data to predict a response. How did I go, by the way, Peter? How would you rate me on that definition?
No, that sounds great. And I think it's very hard to really find a way to explain these kinds of concepts, because there's so much going on. Yeah, I think what you talked about, yeah, finding patterns and predicting the next word, I think all of those things are really important. And I think what really is interesting for me, apart from the kind of technical definition, I think we kind of went from maybe rules-based systems where there was not much data, with supervised machine learning where we used our internal company data, and with generative AI is that we are really now getting access indirectly to kind of humanity's data that was available before. And I think that's how, for me, that's another practical implication, that right now we don't really need to train particularly anything ourselves, but we can just get some of these capabilities out of the box. So if you want to understand a piece of text, I don't need to be a machine learning scientist. I could just do that myself.
Yeah, I think that's that generative AI component where there was a lot of discriminative AI previously to ChatGPT, which was, okay, let's try and classify data. And, if you have an image, I'm going to tell you if there's an umbrella in the image. And now we're in the world of generative AI, which is, generating new content. So it's, okay, tell me to create an image of an umbrella and I'll create it. And I mean, that's how I got into this, coming from a non-technical background, where you all of a sudden have this extremely powerful technology that's interacting with you and that you can interact with it in a very intuitive way. And that I think, combined with that decreasing cost in production that I mentioned earlier, just opens up accessibility to anyone. And it allows us to, like Peter said, troll or ask questions against basically the entire documented data set, or maybe not, the online data set of humanity, and try to make sense of it through the lens of this neural network that is also trying to find patterns and make sense of it too. And that's obviously a feedback loop where, and I think the basis of reinforcement learning, where those neurons, those network, or the nodes in that network, are being strengthened over time, based on the objectives of the model.
Right. Yeah. And obviously, kind of, these things are not perfect. So in sort of when these platforms make sort of mistakes, we call those hallucinations, I think is the term. So would you you guys kind of agree with that, Matteo and Peter? Are you sort of happy with that as the main description for when, the model doesn't kind of give you the correct response?
Yeah, I think it's tricky that. I think it kind of depends on our expectation of it. So I know a lot of the time people would, for example, try and say, create me a biography of this person, and then it kind of approximates to something that looks like a biography of this person, but actually is wrong on the details, and you can call that hallucination. On the other hand, if your expectation was, if you kind of reframe it slightly and say, write me a biography that would kind of look like a person of that biography, which is probably closer to what it's doing, then you would say, actually, that sounds like a approximately right. So I think hallucination is definitely an issue, and I think there are some cases where it is a problem, where it just comes up with the wrong number when you're trying to do a lookup of information in your data set. I think that's a problem. But I think there's an element where I think we need to be careful and have better intuition about what kind of use cases are appropriate or not. So, for example, writing biographies, or I know there were cases before where there were some lawyers asking to write a list of cases that were available previously, that for reference. I think those are just bad use cases, and we shouldn't expect large language models to do them well, which I think is quite hard to. If I was explaining this to someone who never seen a large language model, it's quite hard to explain what the intuition is for what the use cases are appropriate or not. But one thing to add as well is that hallucinations really dramatically reduce with bigger and better models. So I'm hopeful that as we get better models, that we'll just kind of get closer, that pattern matching would get closer and closer to what we need.
Right.
I'm kind of reminded of two quotes, both, or I'm going to say them verbatim, but two quotes from Sam Altman. The first was, I think it was mid last year, and he was being interviewed on hallucinations, and he's like, well, yeah, that's the whole point of the technology. It's being creative, and it's almost what makes the technology special, or what made it special is that, I mean, in the background, to explain it extremely simply, it's just predicting the next word. But there's definitely something more happening there, where you're able to talk to it exactly how you want to, and then get it to talk to you back in exactly the way you want. And that is an extremely creative exercise. Like, for me to tell a technology to tell me the history of America, like in the tone of a pirate, like there's no existing resource on that on the internet, right? But the fact that it can do that is what makes it special. It is creative. And the other quote was more recently, and he said, he was actually at the World Economic Forum, and he said, I would much rather us know that the large language model is wrong 70 to 80% of the time, then know that it's wrong 99.9% of the time, because you should be more concerned when it's right 99.9% of the time and you have to try and figure out when it is wrong. So there is an element of, like Peter said, it's different horses for different courses. You should be really, really specific on what you want to use it for and what it's a good fit for, and even more specific on what it's not a good fit for.
Fair enough. Yeah, no, I think that's there's definitely kind of different views on some of that, and I think we'll probably see that kind of progress in the future. Okay, so just kind of scratching on a couple of the surfaces there, and just a couple of more sort of those definitions or terms. Tokens. What's tokens all about, Peter? Can you give us a little sort of definition of that?
So Andrej Karpathy released right after he left OpenAI, he released a really great video on tokenization, and yeah, he's got a great summary. I'm not gonna try and recap it, but his view was that tokenization is the kind of necessary evil that's the root of a lot of problems with large language models. So in essence, the reason why we need tokenization is that we can't, it helps us more efficiently ingest the text and train those models in. So the intuition for that is that if there are certain words or phrases that are repeated more often, so for example, if the word is yesterday, if you were to encode it kind of letter by letter, it would be quite inefficient way of doing it. But you can just encode it as one thing, one number, the word yesterday. So that's why you kind of go from however many letters to like one, and that's how, the trick is to find the right number of tokens, where the right number of these optimizations, where you've got a high vocabulary of them, so it's quite efficient to then train the models, but you're not overdoing it, that it becomes like too cumbersome, too complicated to do. So I think, if I remember correctly, the typical number of individual tokens is somewhere between, like, for some models, maybe 100,000. For others, I think the Google one was something like 450,000. So that's a kind of range that they're going for now. But essentially, so some of the problems that we're seeing with tokens or that are due to tokens is, for example, maths. So to be able to add in two numbers, it wouldn't just take number by number necessarily, but it would actually take, if it's 1,000, it could be one token, or it could be, but 1,002 could be two tokens, for example. So that, and there are slightly completely arbitrary ways how those tokens divided, which causes a lot of problems for large language models. So sometimes that's why you see there are some trick tests that people are doing. For example, list 10 words and each word should end with D. And sometimes models just completely can't do it at all. And it's not because they're dumb inherently, but just because they can't do it through tokenization. So it's a kind of necessary evil, and we just kind of have to deal with it. And there are other problems as well, such as English is pretty well represented normally in models, but if you're dealing in other languages, then sometimes these models could cost you 3-4 times the amount. And again, it's not because, I don't know, these model providers are evil. They just haven't trained it with these languages in mind. So then tokenization is quite inefficient. So it's a kind of tricky thing, and I hope people will figure out how to kind of go around it. But for practical purposes, one thing anyone can do is you can just Google tokenization, and OpenAI has good public tool where you can just put in a text, and it will show how your text breaks up in tokens. So you can do that, and there are also other open source tools where people have done it for different other models. So it's worth exploring if you're interested. There's also another school of thought of just kind of don't particularly care, just see what works. I think that's okay as well. You don't have to care about tokenization, but if you want to, there are resources for that as well.
Cool. And Matteo, what about things like vectors and embeddings? That seems to be an interchangeable sort of word. What's your kind of take on that?
Yes. So I mentioned earlier, and Peter kind of alluded to it, that all of this text data that the model is trained on is essentially being zipped into a vector database that is numbers. It's like a giant zip file. And then it's, as I said, trying to find relationships between those tokens. So a vector or an embedding is that process of a chunk of data being converted into a vector database into those numbers that I mentioned. Now, this happens for the training data of the model, but it can also be used as a way to increase the context window when you're building LLM applications or interacting with a large language model. So everyone knows you have a prompt. That prompt generally has a character limit. Gemini decided to increase that character limit significantly recently. But previously to that, you were kind of limited. So you had to use files, whether it's PDFs, it could be, text files, you could put in spreadsheets, and that would be converted into this vector database, this embedding. It would become an embedding, which is trying to ground the LLM towards a specific context, just as your prompt would be, guiding the LLM to respond to your prompt. You're giving it this this embedding, this file that's being converted into numbers, which is also acting as additional context to the large language model.
Right, and hence why I think we're seeing a lot of the established database vendors all scrambling to say, well, we can do vectors as well. So that's another interesting angle. We'll see how that develops. Okay, so let's move on to the uses of AI. So we kind of wanted to really sort of get a little bit towards the use cases and discussing kind of those. So in terms of GenAI, what kind of makes sense to deploy, Matteo? What's kind of practical sort of use? Should we kind of just go to Copilot to have our own sort of version of Copilot, or we kind of just use something that's out there? What's your take on that?
It's like a really simple question to answer, but also a very difficult question to answer because, and it reminds me of a book that I'm reading at the moment called the AI Playbook, or the Machine Learning Playbook, or something like that. But one of the first quotes in there is from the VP of Data and Analytics from Verizon, and he says, it's something along the lines of, you can apply machine learning to pretty much any business process right now. And it actually, I mean, it's kind of true. If you really wanted to, you could do it. And that's often a really difficult thing to try and explain in a workshop to a customer or to someone else, is that you really do have a technology now with generative AI that is acting very similar to a human would, where it's able to perceive the world, make sense of the world, or at least the digital world, and then be able to create an output based on that in the form of text, image, video, sound, or code. So that the question of what is a good use case is, there are really obvious examples, and people are making SaaS applications for that. And it's a really good place to start and to experiment, especially with, you said, like Copilot. But I think there's that next level of thinking, which is, let's just look at what you're already doing today and go through a process of understanding if it's a good fit for generative AI. And that is a combination of, does it make sense for the technology? But then the other really important question is, and I don't know what that thumbs up is, by the way, it just seems to happen whenever I'm in calls. The second question is it feasible? And feasibility is not just, can we do it? It's, is there an actually a good reason to do it? And outside of the very obvious applications that are being built, Copilot being an example, even using ChatGPT and building GPTs, I think there should be a question of, okay, A, can we do it? Is it a good fit for the technology? But B, is there a business case? Is probably the simplest way to describe it. And you're going to find heaps of different use cases throughout that process if you do a bit of thinking. But I think it's the distillation of that and actually seeing what makes sense as a first step is really where to go. And I mean, I could go into specific examples, but the things that we look for and things that we tell clients, But I really think it starts with, what are you doing today? Like, let's not try and do something crazy and new, at least not to start. Like, let's just look at what you're doing today and try and make that better using this technology that we now have access to.
Cool. And Peter, just kind of what's your sort of some of the practical uses that you've seen?
Yeah, so I think I'll go through the kind of structure I've got in my mind that I'm using internally as well. So the breaks up. I'll say we can deliver generative AI across both productivity and user experience. So I think those two buckets. And in productivity, you can start with quite low hanging fruit in there. So just adopting tools, I think, is a good one. So I know you mentioned Copilot, easy, just coding assistants, great, just do that. Not very hard. If you've got designers, Adobe Firefly, things like that, again, easy. And we had some really nice results with some other tools for example, scenario.com, which is actually designed for gaming developers. But because what they're trying to do is to have consistent characters, which is actually quite neat for marketing. So if you've got, we had one designer who's taking 2 weeks to create a new asset, but now we can do it kind of in a few minutes. So there are definitely tools out there that is just easy not to overthink it and just use it. And the second category, which is a bit more effort, but it's internal applications. So within that, it's the kind of things where you can't really just take tool off the shelf. You need to integrate it with your internal data sets or between different processes and so on. There probably a very easy version of that is something like custom GPTs, which I would definitely start with. And I think any organization should just have a version of that, where you can put in your custom documentation, you can put in a set of instructions, and now you can just use that. So one good example of that, which I actually was using the other day, is job description creator. So right now, you can either just do it by hand, you can ask ChatGPT, but to actually come up with something that is useful to you, that complies with your tone of voice, with your template, is actually quite fiddly and it's kind of not worth it. But actually, if you have a custom GPT that says, here's our template, here's how we write job descriptions, that's the kind of thing, then you can iteratively improve and it will help you. But within that, also with things like, if you've got customer service agents and you want to help them write better responses, quite often you need to connect it to your internal data sets, policies, then some additional data flows from the conversation, and so on. You probably need more custom application there. And typically what you'll do, what I would suggest, is just tap OpenAI API, whatever model you've got access to, and build a bit of software around it. Not too difficult, and you can get quite nice results. And then as we go forward in that kind of maybe switching over to user experience side of things, there are some applications where we can kind of enable user experience behind the scenes. So one nice general category to look at is that all companies really have a lot of unstructured data that we kind of just forgot about. It just generally was quite hard to use before large language models. So what I mean by that, any conversations we have with customers, email, voice, any customer surveys that we do, all of that information, typically you'll have a few people kind of glance at it and that's it. But actually what we can now do is to put a large language model to use and say, extract me what was the summary, classify it according to my schema, then say, was that an issue that the customer was complaining about? What was the tone? What was the emotion of this conversation? So there are so many things you can kind of do straight away, and it really would work out of the box. Now you can take it even further. It's like, do you want to raise a ticket with your relevant team to deal with that problem? So these are all the kind of things that we can do. And the last point that is probably the most complicated, and what Matteo was talking about in terms of like, is it worth it and so on, it's the user experience facing features. I think it's quite easy to build something that is kind of trivial and probably no one's going to use. And it's okay. Maybe I'm not completely against that. I think it's okay to try, but it's a lot harder to build something genuinely useful. That maybe my criteria for that is that maybe if you can make it useful without ever saying that it's AI, is just a nice, useful feature. That's probably it's a nice way of thinking about it. But there's so many opportunities there. There's some with image generation, maybe voice interactions. Who knows? There are many different things in that last bucket.
Yeah, I think I think I looked at Gartner brought out something a while back, and it kind of just gave you the use cases, and it was, I mean, it might as well have just said pretty much every industry. I'd have saved us PDFs, worth of pages of descriptions, because we're just saying, well, this manufacturing, health, blah blah, and it was just kind of listing. I was like, yeah, but we know those. There's no need to kind of list them all. Sounds like it's going to be applicable to everything, so that's great. Okay, so let's move on to the sort of AI risks and how to kind of mitigate that around security, sovereignty, IP protection, stuff like that. So, Matteo, what's kind of some of the sort of things that you've seen around sort of Gen AI, again, sort of making sense in terms of kind of where we can deploy it, but also what sort of concerns have you seen maybe from from customer interactions that you've had?
Discussing risk is, I think, one of the first conversations that a leadership team should have. It's important to be across all of those risks. One thing I really liked in how you were describing potential use cases, Peter, was that there really is this level of complexity that I think you can look at that complexity not just from feature and functionality. Like, I mean, let's use the example of creating a GPT. You don't need to do like a risk reward analysis for creating a GPT. You just create the GPT, and like if it works and there's a subjective like, okay, this is going to save me a lot of time, then you should do it. But if you're creating an in-production application that's going to touch customers and internal users and work across multiple clouds, then there obviously needs to be way more thought towards, does this make sense? And I think that is very much the same with how the approach to risk should be. There should be definitions across the business on, where do we want to play and where do we not want to play? And then within those categories, buy versus build being an example where if you're buying, there should be some sort of litmus check on data security and privacy policies, of course. But you don't need to boil the ocean. But there should be something really comprehensive for, like I said, building in production apps that might cross multiple clouds and touch multiple different business stakeholders. So I think that people are aware of the risks. It could hallucinate, it could leak data. However, I think that it's more about how do you approach those risks, not to stifle the agility that is required to get value from it. And I'll give you one example of that, where we're building a tool right now that is, it's very rudimentary. It's just taking news alerts or news summaries from the web and summarizing them in Slack in a 5 bullet point summary to help out sales guys do their job more effectively, right? And it's for 20 salespeople to start, but it's a really good example of like, okay, there's not a whole lot of data security or issues that arise from just scraping the web and putting it into a Slack channel. At least we're not really sharing anything about the business itself there. So, and it's playing into that pocket of a really simple use case for generative AI, which is summarization. It does that well, the human's in the loop and gets to validate the summary, So you're able to mitigate whatever risk might come across that specific use case. But like I said, that's a pretty simple thing to build, right? It has a lot of value for the sales guy because it saves him and his BDR a couple of hours a week, and it allows them to make better decisions around who they prospect to. But it's not there's not a lot of risk around that, and any risk is mitigated by, like I said, having a human in the loop to check those summaries. Now, it's all a level of complexity, and I think that's the point there, is that you need to understand where you're going to play, and then you need to have a good process for managing risk to the extent that it's required for the use case.
And Peter, kind of similar question to you in regards sort of data sovereignty and stuff like that. What's kind of your experience? How are you guys kind of trying to mitigate things like that?
Yeah, I think it's a tricky area, and I think so I was generally, when I was thinking about this, especially in my previous roles, was in a bank before where it was a lot more sensitive. I was thinking about how we navigate the risk space, and I was generally breaking it up into three categories. So one are things like societal risks, such as, for example, people using GenAI to break our systems and, I don't know, impersonate others. That kind of will happen regardless of we were doing anything about generative AI or not. That we just need to deal with that. Then there were organizational risks that you deal with at the level of the whole organization, which includes like data security. And then the last category is the use case specific risks, where we need to think about things like prompt injection, if it's going outside or we're taking anything from the outside. Then things like, do we have human in the loop, if it's any kind of decisions involved, user experience, things like that. So in terms of your data sovereignty point more broadly, my personal opinion is I think people are slightly overly worried about that. I think as long as we've got general assurances, such as by cloud providers, that it's the same kind of idea as before with cloud, where we put data, we own the data. Cloud providers not just gonna take all the data and, I don't know, train their models on that. I don't see any particular difference between this and any other product, I don't know, S3 or something like that. There's not really any difference. And I think maybe a lot of the time people get slightly overly concerned because it's AI and has some other maybe concerns. And I think these other concerns maybe start leaking into the data security concerns. And I think that's why also people sometimes saying that was the bull case for open source, that we can run our own models on our proprietary infrastructure and so on. Again, not that I'm against open source, but I don't think that's the best selling point. As long as you're with the cloud provider, what's the problem? I don't really see an issue, but some open source models can be run by maybe newer infrastructure providers who maybe don't have just as maybe secure systems as AWS would or other cloud providers. So yeah, I think personally, as long as you've done your basic hygiene, the basic setup, I don't think there's anything particularly else to worry about, because there's nothing. It's not some magical thing. It's still a bit of software running somewhere. So I think we shouldn't get overly excited about that side.
Yeah, and I think if you kind of have the basics in place, and I did do a mini survey of some friends that I have in the financial and insurance space, and I asked them kind of very rudimentary questions about, do you have a policy against kind of how your employees use things like Copilot? Yes. Do you have like a strategy for AI for this year? Yes. Are you are you piloting or POCing for this year? Anything? Yes, we are. So I think pretty much I think we're sort of at that stage. Also, people like sort of Amazon, AWS, sort of Amazon Q, and so on have kind of, tried to stress very much the fact that they're not actually using it. If they're kind of helping you, if the platform's helping you with code, they're not actually using your code. Apparently they have plenty of Java and JavaScript code internally, so they've trained it on that, and it's not kind of using that. And also on the data side, I mean, even the company I work for, T Systems, offers data sovereign clouds. So there is actually kind of that type of capability where if you're sort of in that space, either in the market sector or a country or a particular block like the EU or something, where you need to guarantee that the data is going to remain sovereign, then you can put it in a sovereign cloud as well. And that's kind of what you want to do. Okay, so let's move on to practically speaking, which is kind of the next bit. And that's kind of really around sort of implementing AI and kind of what that sort of landscape would look like for the sort of the average enterprise. Now, I wanted to really kind of understand that from you guys and kind of what your experience has been of that in terms of kind of your discussions with customers. But before I get to that, I did ask Copilot to kind of see what the, formulate the some ideas around some of the thinking that I had around it. And feel free to shoot this down, but you'll end up arguing with Copilot about it because Copilot seems to agree with me. But I thought, just kind of, I'm very much a visual person. So if somebody can kind of draw me a picture, it kind of makes a lot more sense than, just dry text being, describing something. So what I wanted to do was really say, okay, so if somebody's going to, implement this, what does this actually practically look like for your average normal sort of enterprise? So I came up with kind of a 3-layer sort of build for enterprise in terms of how they can actually implement AI. And I based it around sort of the cloud model of, infrastructure as a service, platform as a service, and software as a service, for the lack of a better sort of description. And it just kind of prefixed us with AI. So you have kind of AI infrastructure as a service, AI PaaS, and AI SaaS. And the AI IS, or infrastructure as a service, is kind of really essentially building your own model from scratch, your foundation model kind of from scratch, and you kind of go up the stack that way. The AI PaaS is kind of really training an existing model. So you're kind of fine-tuning it to, do a data market sector, whatever it is. And then the AI SaaS is where you kind of just give up on that, say, I can't really do any of this, too expensive. Or, hey, we just need it to be, trained, or we want to train it on our data, or we want to kind of use something that's specific in our market sector. So we'll kind of present our data sets, and then we'll make use of it that way. So those are the 3 kind of models that are ran by Copilot. What's your take on that, Peter?
Yeah, so I think that makes sense, and I would say that for anyone who's looking to start, I would absolutely start with the last one. It really is. There is completely no point overthinking it. What I would suggest for people as they're thinking about it, literally what I do sometimes, if I've got an idea for a use case, you just open ChatGPT, copy paste things, prompt it, and just see whether it makes sense what you're getting out. So for example, when I was exploring ideas about analyzing customer reviews, that's literally what I did. And that way you can have internal conversations, not just on hypotheticals. You can actually just show people how it works. And later, you can take a smaller model, cheaper model, optimize it. If it's really necessary, you can fine tune it. Although I think that slightly people, I think, get overexcited about fine tuning because I think they want to do something technical. But I think a lot of the time it's really not necessary, and you should probably only do that once you're really exhausted all of the other options. I would say if you've been prompting it for a month and you can't get it to work, then fine tune, but I wouldn't just go in straight with fine tuning. And in terms of building your models, and unless you are a really large company with very specific needs, or in a completely different field, such as, I don't know, maybe biology or something like that, I probably would never ever go there. Because even if you look at companies like AWS, I don't think they've been that successful building their models, to be honest. Even companies like Google, that you think are amazing, they release open source models, which don't seem to be that much better than Mistral models, for example, that we had around for a few months. So it's really hard to make a case for really saying, yeah, we need £5 million to build another 5B, 7B, 2B model that will kind of probably be worse than the ones that are already out there.
Matteo, what's your take on that?
I agree. If you're a business that's just starting, then you will have enough. And this is, I think, really one of the, I don't know if it's funny, but it's the most interesting thing about generative AI is that the rate of technology is improving so much faster than the rate at which the business can adopt it. And every week or two, there are a new round of things that make sense to test and try as a business. And having a like Peter said, having a mechanism to test and rapidly iterate on use cases is really, really, really important. And GPTs provide a perfect playground for that. And I mean, you could build something internally if you really wanted to, but the easiest way is to open up a GPT and start experimenting, or buy an application that you know is working relatively well for others and just test it. And without overcomplicating things, I think most enterprises, definitely enterprises, could sit there for 3 to 6 months and still get like significant value. So I agree with everything you said, Peter, and I would just, yeah, I would double down on that point of keep it simple. You know, either use a no code like a GPT thing if you want to create something custom, or use an application that's already been built and has you know, something validated against it. To your point, that character tool that you mentioned, Peter, that sounds really cool. So there's so much there to try, like keep it simple. And I think the first point I made in this whole conversation would be like, do it if there's a tangible benefit. If you're really going to invest a lot, then, you know, make sure there is a significant benefit in doing so.
Cool. Okay. Well, I'm glad that we're sort of in agreement in terms of the 3 layers that I laid out. So that says I'm very happy with that. That's quite cool. That's something I can take away. Excellent. Okay. Yeah, and there was, I think, some other stuff that I noticed. Somebody kind of put out some stuff around sort of you know, the AI sort of software stack. How would that look like? A chap, I think, by the name of Andreas Karpov. I may be butchering that name, so apologies if I am, but I will include the links to the post that he's done actually on in the description of the video. And I think you guys have kind of done that as well, so we'll include some more of that. Okay, so let's move on to the impact of AI. Now, what I'm going to do, I think, on this is probably best if I kind of maybe mention the 3 sort of main categories, and then I'll let you guys kind of comment and see where you want to go with those. So first was kind of obviously concern around the sort of the job market and kind of losses and creation. We've seen lots of kind of, you know, concerns around sort of, you know, jobs being lost, but also because of AI, of course, but also creation of new jobs as well. So new titles kind of coming in, things like, you know, data scientists and various other things kind of becoming a lot more, you know, interesting. So that's kind of one space. The other space was around computing resources. So how much compute resources, you know, AI requires if you're kind of going to go and do that, you know, sort of AI infrastructure as a service, you know, sort of thing yourself. We've seen various articles from, you know, Microsoft looking at, you know, using small modular reactors, nuclear reactors, SMRs, for future hyperscale data centers, advertising for things like power managers or nuclear power managers, kind of job adverts going up. I think I've covered some of this in the Cloud State of Play as well. So I'll maybe try and include some links to that. At their Ignite event last year, they announced their Maya Accelerator, AI accelerators. Same thing really with Google and Amazon with Q and Bedrock and various other things. So that kind of compute resources being an impact. And then finally, around sort of power consumption and sustainability. So jobs, compute resources, power consumption. Peter?
Are we covering all 3? Or
Well, pick on anything that you like, all 3, one, and just go with it.
yeah, and the only thing that came to mind on the first point was a really interesting perspective from Jensen Huang in his recent podcast with Acquired. I'm sure if it became there was a really, really famous quote that he made in there that I can't remember now, but I thought just as interestingly was his perspective on the labor market in the short to midterm. And he made this really good point that if you're a productive business that has a lot of good ideas, when you become more productive, you have the ability to, ideally, if you're more profitable, to fund more good ideas. And we know from generative AI that it is really good at automating tasks. It doesn't replace humans or entire jobs. It's really good at making the completion of tasks more effective. And if you take that into a lens, you're saying, okay, well, there are tasks that a human is doing that are going to become more easily completed by generative AI and the surrounding technologies. However, that human is just going to become more productive. And if a business is more productive and they still have a lot of good ideas, which every business does, then they're going to continue it to expand once they become more productive. And I think that it resonated with me, because what that means is in the short to midterm that we will see businesses becoming more productive, yes, but as they become more productive, it just means that they can execute faster. And to execute faster, you're still going to need more and more humans, at least in the short to midterm. So I think that's a promising outlook. The other really important point there is that there are many, many professions where you need certifications and accreditations to be able to do the job. So you can't really, even if a technology can do the job of that person, then you still need someone certified and accredited to perform it. So those are the 2 points that I have on there. I mean, I have a third on the story of Visa and how they created a data center, but I might pause and get Peter's 2 cents before and if I even tell it.
Yeah, I think that makes sense. I agree with that, and I think when people talk about massive job losses, I think they really overstate the AI capabilities, and I think we are quite far away from AGI or anything that approaches that. And I think a lot of technically minded people forget all of the maybe frictions and all of the realities of the world that we exist in. So, for example, even for an engineer to do their job, they're not just sitting around coding all day. They need to go to a meeting, understand what needs to be built. Then they need to, log into this system and pull documentation from here and get credentials from there. There's so many things that need to happen. And there was, for example, there was a big release, high-profile release of a first software engineer. What was the name?
Devin, or
yeah,
is it
Devin. Yeah, something like that. And while it looks cool and it's certainly a step into that direction, it still stumbles around. It still makes a lot of errors, and obviously things will get better and so on. But even if you imagine a really good bot like that would create software, it still doesn't have enough context to understand what is it that we need to build, why do we need to build it, what would be meaningful for our users, what general architecture should we follow, what our coding standards, like all of these things that I think people forget that exist in reality. And that even as Matteo was saying, like, it's task automation. Even if you automate a lot of tasks, there's still so much context, so much other friction that is not really tasks. And I think especially as we automate more and more, I think there's so many more people who have jobs who don't just execute tasks, but there are a lot more just come up with new tasks and think about new ideas and try different things. And there you need to be much more flexible than our current systems. So I think we are very far away from this. But you know what? Now we're speaking, OpenAI are going to release GPT-5, and all of this will look completely stupid for what I just said.
Yeah.
And not just that, but did you see the demo with the Figure 01? Is it OpenAI and Figure 01 video?
Yeah,
I thought that was that was quite interesting as well. So we'll see. Okay, and I think we've maybe covered the kind of compute resources and sort of the power aspect of it. I will try and include some more links in the description of the video. There's a lot more obviously to cover, but obviously we can't kind of really do all of that justice in this particular talk. I do want to kind of wrap up with just a little bit of sort of advice, really, kind of around how enterprises can really sort of adopt a sort of strategy, AI strategy, and kind of start. We touched on it a little bit. We kind of maybe said look at the AI sort of SaaS approach as a first point, maybe kind of play with some of the open source models and things like that. But Peter, what would be kind of your maybe just a little bit of practical advice, and maybe just drawing on some of your experience as well?
Yeah, I think the most important thing is make sure you've got security-approved access to large language models, and that people and your engineers got access to that. I hope most people have done it now, but I know there's still limitations with rate limits and so on. So provisioning on that, I think, is the most important. then I know we talked about talent, but probably the biggest bottleneck to actually delivering this is not having people who know what they're doing in this space. I think that's a massive limitation. We could do with 100x more people easily. So I think having some teams who know how GenAI works, and probably having more like a focused team that would maybe partner with other teams, that's probably the way to go, at least in the short term. Not forever. I think everyone should know how it works in the longer term. But I think the pragmatic thing to do is to have a team that can focus on that. Yeah, now I would say just I wouldn't probably over-engineer technology, and the whole kind of tooling landscape is too hard to know exactly what will work. I don't think anyone knows, or not what will work, but what to even need to work. So I would say start simple, just start building applications and see how you go. I think that's probably the best way to do it. And I would say one thing also maybe to say is that in my experience, it's a lot more about software engineering than data science. So one thing I would also say is that some people can easily transition from one to another, but I wouldn't pull your data scientists off of machine learning projects. Probably let them do machine learning stuff. There's probably lots more to do. But take those people who are particularly skilled in GenAI or want to be skilled in GenAI, and then let them do more software engineering type things. So I think that's probably, at least in the short term, that's how I think about it.
Matteo, what's kind of your advice?
I think just as ChatGPT has become accessible to like primary school or high school students, if we were to flip that of like, what's the relevancy of that to enterprises, is that there really is the ability for you to democratize access to this technology. And to Peter's point of, yes, secure access. But what that means, and we're actually seeing this with automation right now. If you look at no code and low code automation tools like Wacado, they just published results that 44% of their automations are being built by non-technical teams, which is pretty wild, right? That a non-technical team can get into a system and start to connect dots between other systems to save themselves time.
Yeah.
And I think that as there is this trend of, okay, cost reduction and more intuitive user interfaces and technologies like large language models, you have an opportunity to unlock a lot of the, let's call it shadow process. The term of shadow IT or shadow analytics is used really commonly in the respective teams, but there is a lot of shadow process, right? Things or tasks or, really small granular things that every human is doing in your business. And now that you have a technology that is quite intuitive and interacts with us in natural language, just as we can interact with it in natural language, there is an opportunity for you to enable your business users or non-technical business users to get value from the technology faster. And that's not to say you give it to everyone. I think that you really need champions, and we see projects that work well is not where everyone is using it. It's where you have a subsect of employees using it, and you have, like Peter said, either working groups that are specifically focused on it. And you identified the champions because you don't want everyone creating. I've seen a lot of really bad GPTs and a lot of really bad pilots and POCs like run by non-technical people this year especially. And the point is not to let everyone go crazy, but the point is to find the champions and give it to as many people to where you can find the person within the business or a specific business unit that is savvy enough to really see where this moves the needle. So outside of the very important and necessary governance and risk management processes that you should have, finding the champion and realizing that this is just as much a grassroots up. So as soon as you can shift some of that responsibility onto those non-technical business users that can act as champions, you should, because that's where I see all of the innovation that we're working on right now is from there. Whether we're obviously engaged with technical teams within enterprises, but the ideas themselves, like the golden nuggets, come from these business users that that understand their business process very, very well, but also have enough aptitude when it comes to technology to think of good use cases, and there should be some process around that too. Like I said, that just because the technology can do it doesn't mean you should build it, but you definitely need to find the champions and realize that it should be a grass ups movement just as much as I don't want to say leadership down, it's more of the tech down movement as well.
Fantastic. Okay, well, I'm sure we can go on talking for a lot longer about the topic. There's so much more to explore in other areas to go into. I think we'll draw a line for this particular talk. Yes, this has been really fascinating discussion on this really sort of ongoing and developing subject of AI and everything around that. As I said, yeah, no doubt there's more kind of to do. And discuss around that. Maybe we'll kind of revisit it in a future talk. I want to thank Peter Gostev and Matteo Castiello for your time, your insights, and your thought leadership. Has been really fantastic having this discussion with you. I really appreciate all your opinions. Links will be in the description of the video on everything that we've talked about and then some. I want to thank you all guys for watching. Please continue your support of the channel, and we will see you next time.
Guys, it's Matteo Castiello here. Please make sure that you subscribe to Richard's channel, and bye for now.